Hi, welcome once again to another lesson. In this lesson, we'll be looking at to find the sum of a finite geometric series. I'll start by helping us see how to prove this formula itself for finding the sum of a finite geometric series. Now let's get started. Now if Sn is actually a series, Sn is the sum of a series, that's the sum of T1 plus T2 plus T3 plus up to the last term, Tn. A lesson where we explain how to come up with the nth term of a geometric series, we understood that Tn is equals to a r raised to the power n minus 1. So that if Sn now will be equals to a, that's the first term, my a, plus ar, that's the second term, n minus 1 here becomes 2 minus 1, plus the third term, ar raised to the power 2, it continues this way up to ar raised to the power n minus 1, which is the nth term. Now let's multiply. Let's call this equation 1. Then we'll multiply equation 1. Let's multiply it by r. It becomes r Sn. It becomes ar plus ar squared plus ar raised to the power 3 plus continues this way up to ar, because this becomes ar raised to the power n minus 1 times r, that becomes ar. N minus 1 plus 1, that becomes n. Now, so we have ar raised to the power n rather. So let's call this equation 2. Now we'll subtract equation 2 from equation 1. Let me rewrite it for simplicity's sake. Sn is equals to a plus ar squared plus up to ar raised to the power n minus 1. Now on subtracting this, it becomes minus r Sn is equals to minus ar squared minus ar raised to the power 3 plus, all this is become minus because of subtracting, up to minus ar raised to the power n minus 1 minus ar raised to the power n. When you multiply this by r, this becomes r raised to the power n, like we saw here. Now, ar minus r gives way ar squared minus ar squared minus ar3. There will be a plus ar3 here, definitely, minus gives way up to ar raised to the power n minus ar raised to the power n. So at the end of the day, I'm left with Sn minus r Sn is equals to a minus ar raised to the power n. Now let's factorize. Sn about 1 minus r is equals to a into 1 minus r raised to the power n. So that Sn for the sum of a finite geometric series is the same thing as a into 1 minus r raised to the power n all over 1 minus